These are going to be the solutions for the IXLs from section U past 60. So I'm going to breeze through these really quickly because this is the second time that I'm trying to record this video. And the first one wasn't saved, so I'm going to go even faster than the first time. But that's okay, you could just put my speed slower. Okay, so it's asking for x. What we learned in this section is that all the way around the circle is 360 degrees. So 2x plus 100 plus x plus 74 equals to 360 degrees. And then we got to solve for x, so we're going to combine like terms. So we're going to get 3x plus 174 equals 360. Subtract 174, subtract 174, that cancels out, and we get 3x is equal to, if it was 160, it would be 200, but it's 16 less, so it's going to be 184. Divide by 3, divide by 3. That's not right. Let's do it again. So we got 360. Let's just use the calculator. 360 minus 174 is equal to 186. And then 186 divided by 3 is equal to 62. So x is equal to 62, and that's what they're looking for. So that's how you do one of these. Okay, next section. U3. No, I mean U6, sorry. Okay, so let's skip ahead to where it gets a little tougher. A little more. Okay, so in this section we learned that if two chords are congruent to each other, then that means that they subtend the same arc measure. So in this case, we know that this arc is the same as this arc. Therefore, that implies that this chord should be the same length as this chord. Since they're the same length, that means you could set them equal to each other. So that would be the appropriate equation in this case. So we're going to say 3t is equal to 18, and then all we got to do is divide by 3. Divide by 3, this cancels out, and we get t equals 6. This equation wasn't that tough. So if you get a tougher one, just stay tuned to the next sections where there's going to be tougher equations that I'll be solving, in case you forgot how to solve harder equations. But that's the gist of U6. So let's go on to U7, which is tangent lines. Okay, let's jump ahead to past 60. Okay, so in this one, we learned that if a line is tangent to a circle, then it creates a 90-degree angle where the tangent line intersects the radius. The remaining two angles, this 32 and this x plus 2, they have to add up to 90. So that means that's going to be our equation that we're going to write. We're going to say that the 32-degree angle plus the angle expressed with the x plus 2 should add up to a total of 90. And then we have to combine like terms and then solve for x. So we're going to add 32 and 2. So we're going to get x plus 34 is equal to 90. Subtract 34, subtract 34. This cancels out, and we get x equals 56 degrees. Okay, let's see if there's a harder type. So we got 56. This one's kind of the same thing. Let's see if we can get a harder one. No, same. This one's better. So this one's a little bit tougher of an equation. So for this equation, it's the same scenario. SQ is tangent, which makes this angle 90, which leaves another 90 degrees between the both of those, S and P. So that means that 8x minus 8 plus the other one, 8x plus 2, should be a total of 90 degrees. So when you combine like terms, the 8x and the 8x combine to give you 16x minus 6 equals 90. Add 6, this cancels out, and you get 16x is equal to 96. Divide by 16, divide by 16. X, I think that's 6. Pretty sure that's 6. And they're definitely asking for x. They're not asking for, like, the angle measure. So we're done. Okay, I think that's good for U7. Let's go to U8. U8 actually I'm not going to do because all that happens is that they ask you to do it with decimals, which is not much of a big ask. So let's do U9. U9 is where we first learned that there's a specific relationship between a central angle like G and an inscribed angle like I, as long as, actually let's do it in two separate colors. Let's do I in blue. As long as when you trace out the sides of the angle, as long as they meet at the same places. So these two meet at H, and they also meet at J. When they do, then that means that the central angle and the inscribed angle have a special relationship, which is that the inscribed angle is half of the central angle. So this would be 64 if you divide by 2. So let's go do one of the harder ones. Okay, so this is probably the hardest type. So notice that we have this inscribed angle, 4x, and if we trace out its sides, it meets the circle at F, and on the other side it intersects the circle at E. Now let's look at H. H happens to intersect the circle at the same two places. If you trace out the side length, it goes to F, and if you trace out the other side length, it also goes to E. So both of them actually subtend the following arc that I'm going to do in a lighter color, gray. So it subtends this arc. They both subtend the same arc, which means that they're both actually the same angle measure. They both have the same angle measure, which means that you can set the equations equal to each other. So we're going to say that 4x, the angle expressed by 4x, should be equal to the other angle expressed by x plus 36. And then we're going to go ahead and solve this. We got to bring this x from the right-hand side over to the left, but we got to do it by subtracting. So we're going to get 3x equals 36, divide by 3, this cancels out, and we get x equals 12. Okay, let's do one more type from this side. Oh wait, we're not done yet, because I got the value of x is 12, but they're asking for angle G. So that means we have to take this 12, and we have to plug it into 4x over here. So actually, measure of angle G is equal to 4 times x, and when we plug it in, we're going to calculate 4 times 12, which is 48. So it's 48 degrees. So that's the answer. So you got to be careful whether they're asking you if it's just x or if they're asking you for the angle. Okay, let's do one more because I'm pretty sure I got 48, right? This is a similar type of question. I'm not going to do that one. Let's see. 10 add 29 is 60. This should be 6. Okay, here we go. This is good. This is the type I'm looking for. So this is probably a little bit easier to set up the equation yourself. The other one, I think, was kind of a little bit of a mind blow with the fact that they both open up to the same arc and that you were supposed to recognize that they were actually equal to each other. This one, you just use the more common relationship, which is that the central angle should be twice as big as the inscribed angle. That means it takes two of these, two inscribed angles, to equal to a central angle. So that means that one of the equations we could write is we could say that 2 of the inscribed angles, 2 times 2x, should be equal to just one of these, so just 2x plus 60. And then we got to solve this. So 2 times 2x is 4x equals 2x plus 60. Subtract 2x to get all the x's on one side. This cancels out. We get 2x equals 60. This divide by 2, this cancels out, and we get x equals 30. Now, 30 is not what they're looking for. They're looking for the measure of angle SRT, which is over here. And measure of angle SRT is equal to 2 times 30. We're just plugging 30 into x. So that gives us 60. So that should be the answer. Okay, I think that's enough for U9. Now we can go on to U10. So let's look for a hard one. Okay, this is a pretty good one. So, okay, so what you learned in this section is that this angle should be 90, which means that the two red angles together have to add up to the remaining 90 degrees for the triangle. Now, in some of the types of questions you get, you would actually get some other expression here, like 2x or whatever. In this case, we're not getting anything. So we can't just go ahead and write x minus 31 plus 2x equals 90, because we're missing this one. By the way, this is the type of equation you would write in this section, because those two red angles should add up to 90. So you should get an equation like this, where you're taking one of them, adding it with the second one, and equaling it to 90. Anyway, so how do we do this one, since they didn't give us the second one? Like, this is not actually 2x. I just made that up as an example. Well, the key is that this is an isosceles triangle, because this side is the same length as this side. That means that you can actually use this expression here. You can use the same one for the other side. So we get x minus 31. We could also call this side, since we know they have to be the same thing. So we're going to do x minus 31 plus the other x minus 31. That should add up to 90. And then we're going to go ahead and solve for x. We're going to combine like terms, so we get 2x minus 62 is equal to 90. And then we're going to add 62. This cancels out. Add 62. We get 2x is equal to 152. Divide by 2. Divide by 2. X is equal to 76, which is what they're looking for. They're looking for x. Okay, I think that's good enough for U10. Let's go to U11. Okay, in this section we learned that opposite angles of a quadrilateral that are inscribed in the circles add up to 180. So let's go to one of the tougher ones. This is a good one. So the two angles that are opposite each other have to add up to 180. So we're going to go ahead and write out that relationship as an equation. So the x plus 35 angle plus the x plus 43 angle should be equal to a total of 180. And then we're going to combine like terms and solve. So we're going to get 2x plus 78 is equal to 180. Subtract 78, subtract 78. 2x is equal to 102. Divide by 2, divide by 2. This cancels out, and then we get x equals 51. And that's what they're asking for, x. So that's the answer there. That's pretty much the type of question you can expect after a SMART score of 60 in this one. Okay, now we're going to go to the hard one, which is U12, and do a couple of examples, a few different variations from this section. So let's go to 60. Oh, that's right. So this one, they're just all like the same type because they're all just hard. So, all right, let's look at this first one. So it says find a measure of of arc AB. So arc AB is this black arc up here. And if you notice, it's part of this longer arc from A to C, of which we know this portion of it from B to C. Actually, I'll highlight that in a separate color. So we know this blue portion is 99. Also, if you look back into the quadrilateral, you see this angle that I'm going to use a darker red. This angle opens up to that red arc, and it's 79 degrees. So if you double that, that'll give you the arc measure up here, which is 158. 79 times 2 is 158. And then if you take the 158 and you subtract the 99 portion that they gave us, that leaves you with 59 for the black portion, which is the portion that we were looking for. So we'll plug 59 in, and we'll plug it into IXL just in case, just to make sure. 59, submit. There you go, it works. All right, let's see what else we have here. This one's pretty easy, but let's just do it anyways. So this is angle D right here. If you follow its angles and you trace it out, it opens up to A and C, and then if you go ahead and trace out the arc that it subtends, which is like this peach colored one, you see that we actually have information for both parts of the arc. So the entire peach arc is 128 plus 86. Here we get a 4, add 1 here, that's 3 plus 8 is 11. So we got 214 degrees is the entire peach arc. And if you want the inscribed angle, the relationship is that it's half as much. So you're going to take 214 divided by 2, and that gives us 107 for the red angle. Shh. 107 degrees. Okay, so let's plug that in and see if we get that right. 107. Submit. Okay, good. And then let's see if this is a good one. We can do just one more. Yeah, I think this one's pretty good. This one looks like it could be a little complicated, so let's do this one. All right, so we're looking for the measure of angle C. Angle C is down here in blue. Let's trace out the angle sides. Let's grab a lighter blue to trace out the arc that it subtends. Okay, so if we knew the light blue arc, then we would just divide by 2 to get the blue angle. Now we're going to be able to get the light blue arc, but by using this red angle, 102, right here. So this red angle opens up to this light colored reddish arc. Of which we know this portion. So if you take the 102 here and you multiply it by 2, that'll give you this. 204 is the entire length of the light red arc. Then you take the 204 and you subtract the 76, then that gives you, well, if you subtract the 74, you would get 140. We're subtracting 2 more, so you're getting 138. So 138 is this part that I'll color in green, 138 degrees. So if you want to find the blue arc, the blue angle, then you just have to take, well, let's go ahead and put that. So this is 138. So the green part is 138. The rest of the light blue arc is 138 plus 48. So you take the 138 plus 48. That gives you let's just do it. We get here 6, 1, so we get 8, 186 degrees for the entire light blue. And then you divide that by 2 to get the blue angle, which would be what? 98? No, 93. So 186 divided by 2 equals 93 degrees. And I hope I did all that arithmetic right. Delete 93. No. Well, I must have done some arithmetic wrong. But I think you guys get the point with all 3 of those. Anyways, the bell's about to ring, so I gotta stop. And I don't even know if this will record it, so hopefully it's not too long and it records it. All right.